So today's agenda is we're going to be talking about how the MLab platform is changing, and we'd like to go through some measurement service updates. Like to go over give an overview of why we are diversifying contributors. We're going to talk a little bit more about those specific infrastructure partners, and then talk about the host managed deployment program. So with that, I'm going to pass it to, well, first, I'll share who the speakers are. So we have this great lineup. We have Austin Spires from Fastly and members of the CS&S MLab team, Lai, Nathan, and Roberto, and then Stephen Soltesz from Google, who works closely with MLab. So now I'll pass it to Roberto.
Hello, everyone. I'm Roberto Dauria. I'm a platform engineer at Measurement Lab. And today I wanted to start by giving you a preview of the analysis we've done on single stream MSAC data versus NDT7. To give you some context, MSAC is a new measurement protocol that expands NDT7 with multi-stream capability, some new metrics that were not previously available, and configurable options such as number of streams, stream duration, congestion control algorithm, etc. The first thing we wanted to verify is that since MSAC is an extension of NDT7 to support multi-stream, single stream MSAC should perform the same as NDT7. And we expect that to be true unless there are implementation bugs. To do so, we ran a trial between February and June this year on speedmeasurementlab.net, where users would run both clients in random order to minimize the effect of shapers if one test always runs first. And these are the PDF and CDF download throughput for this trial in between these dates. Now, when I first plotted this data, there was something very strange. The shape of the curves was pretty much the same, but the MSAC one was shifted to the right, meaning MSAC single stream appeared to be faster than NDT7, and that was unexpected. While investigating the possible reasons for that, I noticed that by setting a lower threshold for what we consider a valid test, which is usually 9 seconds for a test that's supposed to take 10 seconds, when changing that from 9 to 8 seconds to 7 seconds, etc., the amount of tests, the MSAC tests included to generate the plot increased, and the two curves started to overlap more and more precisely. The one you see here is with 8 seconds, and they're very comparable. That meant the MSAC tests, for some reason, were shorter than the expected 10 seconds. Next slide, please. Here you can see the same analysis with mean RTT data. As for the previous plots, blue is MSAC and orange is NDT7, and we use the same threshold for a minimum test duration of 8 seconds. Initially, this graph suffered from the same issue. Next slide. So at some point, I decided to look at what happens at the beginning of a test. And I used two new metrics that are available in MSAC and were not available in NDT7. Basically, MSAC records two different start times for the test. There's the sockets accept time, which is the very beginning of the connection, and there's the first byte time, which is after TLS negotiation and the WebSocket upgrade, so the time when the test actually starts. What's in between, we call it handshake time. We expected this to be reasonably short for most clients, but what we actually found now that we have these metrics is that there's a pretty long tail of clients for which the handshake time is longer than 1 second, up to actually 4 seconds. And these tests were being excluded by the previous analysis. So This actually allowed us to identify a bug in how MSAC calculates the test time, because it starts from the connection start time and not from the first byte. That doesn't affect the throughput calculation, but it affects how long the test runs for. And so we're able to fix it. After accounting for this, by setting the lower threshold, the single stream MSAC performance pretty much exactly overlaps with the NDT7 performance as we expected. Next slide, please. So we welcome independent analysis of the same data. Here are the tables that I used that you can query. There are a couple of caveats to be mindful of. For NDT tests, one row in the NDT7 downloads or uploads table equals one test. But since MSAC tests in general can be multi-stream, one test equals n rows. And these rows have to be aggregated somehow to compute throughput in RTT, etc. There isn't a single way set in stone of aggregating streams. There are several options which are represented here. And we decided to do from the first connection to the first stream that ended. But for example, another option could be from the last connection to the first stream that ended, meaning the time when all the streams were running. So there are options. The important thing is to remember to aggregate the streams. Otherwise, you're only looking at one of multiple streams for that test. Now I'm going to pass it to Lai, who will talk about diversifying contributions to MLab.
Great.
Thank you.
Thanks, Roberto. And, if there's questions on what Roberto just presented, we'll return to Q&A at the end. But now I'm going to talk a little bit about our strategic plan to diversify contributors. So as a reminder, when MLab was founded in 2008, we were created as an effort to align efforts in industry, research, and public interest projects, particularly with the goal of measuring the internet openly. And as we've been talking about over the past few years, in particular in March, we are evolving the way that we think about what that means, and in particular, looking for more contributions so that we can measure more parts of the internet, expanding our vantage points and overall having more representation of what it is to measure user relevant internet. And so our goal is to expand MLab's platform to measure more of the internet from new network locations. And today we'll talk a little bit about that progress and what we've done on a technical, from a technical perspective to enable more of that, more of the strategic goal. So the next slide, just to give a historical overview with very cute pictures that I might add. Historically, our servers have been placed in interconnection points exclusively, meaning that we've always been outside of access networks. Starting with our move to cloud, we did that so that we could expand beyond that one vantage point, and including but not limited to interconnection points, so including cloud networks, starting with Google Cloud. And our goal with that was to measure more user relevant vantage points and more representation of where content is hosted for users. So that effort started, and then from there, what we updated in March and what we'll kind of overview again today is our efforts to make that possible with physical hardware as well and other types of networks. So more into the edge and more into access networks. And so as of today, or as of this effort, I should say, when this effort started, we have started to measure both on and off net. And this is overarching, this is towards the overarching strategic goal of having more contributors and more representation of the internet. So next slide. And so as part of this effort, we're looking kind of around the space, looking for partners that looked like there was alignment in working in the open and working in the public interest. And we came across Fastly's Fast Forward program and saw a lot of alignment in the way that they're thinking about investing in open source and powering communities in that way. And so we applied and were happily accepted into Fastly's Fast Forward program. And Roberto later on in the presentation will talk about what we hope to see from that collaboration, different ideas that we have. We'd also be really interested in yours as well. But first we'll ask Austin from Fastly to talk a bit about what the Fast Forward program is and what it means that we're now a member. So Austin?
Yeah, thank you. I'm Austin Spires, and I work in Fastly's developer and open source programs. And one of those programs that I'm delighted to oversee is our Fast Forward program, which you can see in the slide is the way that we support open source, open education, and open research through free services and support. Some of the program members that you might be familiar with include most of the major package managers. We work with the Linux Foundation to support kernel.org. We support Ruby Gems, PyPy, the Kubernetes project. On the education side, we support Scratch if anyone in your family is using Scratch to build their coding skills, as well as Khan Academy. And on the research side, we support the HTTP archive with distributing their research. We do have an application process, but quite frankly, Measurement Lab really wasn't much of a difficult decision. The research that you're doing is exceptional, and we want to do everything that we can to support the greater research community and come together across the community to make measuring the internet a little bit more effective. So I'll pause in case there are any specific questions. Also, I'm more on the program administrator side rather than the research side, so I might have to take some of the questions back and bring you more concrete answers. But we love the work that this community is doing, and we want to support you in any way that we can.
Any questions specifically for Fastly?
Well, if anybody has any questions afterwards, I'm happy to answer them offline, and thank you very much for the time.
Maybe if you could just pop the link in the chat for the Fast Forward program.
Absolutely.
Yeah, Lai's added that, Timur, so please take a look. And then with that, we can move to Roberto to talk more in depth about what we hope to do.
Thank you. So Fastly's Fast Forward program gives us the opportunity to expand our server capacity by deploying an NDT server on their edge nodes. And this will provide more vantage points for on-net measurements to our users, alongside the off-net measurements that we historically provided, and possibly improve performance in some areas of the world. In order to do so, there are a few key challenges that we're working on with Fastly's engineers at the moment. Firstly, the code running on Fastly's compute platform is compiled to WebAssembly. It can be written in Rust, Go, and JavaScript, if I'm not mistaken. It is compiled to WebAssembly, and it doesn't seem to currently support running WebSocket servers. So that's something that we're exploring with our engineers. Another challenge that we identified, which we also want community feedback on, is related to the availability of TCP info metrics. TCP info metrics come from the kernel, and WebAssembly binaries can't usually access them unless there's an API made available. Since we need to keep seamless compatibility with all the existing client integrations so they can use these new servers, our first idea is to replace the TCP info metrics with synthetic metrics created from the application level ones, and label the resulting data appropriately so that researchers know that that TCP info is not from the kernel, but it's from application level metrics. Similar issue for the same reason is that we probably won't be able to control the congestion control algorithm that's used by the NLT7 test. So we might need to use the default one on Fastly servers. So that's another thing that we're looking at. Now I'm going to pass it to Nathan, who will talk about how to contribute to the MLab platform. Thank you.
Hi, as Roberto said, my name is Nathan. I'm a platform engineer at MLab, and I was just going to give a quick overview or recap of the ways to contribute infrastructure to MLab's platform. I'll start with row 1 of this slide, which is the full, what we call the full site. And this was MLab's platform up until about 2 years ago. This was the only way to contribute. And it was 4 servers, a switch, a /26 IPv4 prefix, and a 10 gigabit uplink to the internet. That is, as you can imagine, a fairly high bar for all but the largest network providers. So earlier this year, we introduced a scaled down version of that, which we're referring to here as a minimal site. And that's just a single server and a /28 or /29 IPv4 prefix. The reason we support those 2 prefix sizes is that a /29 will work, but does not currently support all of the experiments that are deployed on the platform today, but only about 3 of them. A /28 supports all of them and gives us additional room to grow in the future. As Lai mentioned earlier, about a little over 2 years ago, we started introducing cloud servers, and today we have about 1 measurement site in every Google Cloud region. And the final line in the final row here is about one that's actively being developed, referred to as a host managed server. And this is not managed by MLab at all. And the entry, the bar to get into this one is a lot lower than possibly all of the other ones. It requires just a single physical or virtual machine, a single IPv4 address, a single IPv6 address. And we expect that this will allow the possibility for a lot more network providers and a greater diversity of locations to participate in the MLab platform. It is not quite ready yet, should be ready early this coming year. And so next slide here. This plot right here is just showing the relative percentage of tests that we're going to cloud sites, to the cloud sites that we have deployed in GCP today. And as you can see, in 2022, it was low. It ramped up to about 35% earlier this year. And then you see a disruption, and then it lowers down and steadies out at about 25%. The reason for the reduction is that it became clear after a while that while cloud is great in a lot of ways, egress internet traffic in the context of a throughput test is exceedingly expensive. And so what this highlights is that the physical platform is today still very relevant and important. And I'll note also that in the past, this year, 17 of the Google-sponsored physical sites were retired, and we expect to see that trend continue over the next number of years, which makes other people contributing infrastructure to the MLab platform all the more important. In this past year, we only launched 1 new physical site, which is generously donated by a fiber ISP in the Pacific Northwest called Ziply. And we hope that they will contribute 2 more in Seattle and Portland. That's to be determined. And so I will hand it off to my colleague, Stephen, to elaborate a little more about the host managed deployments.
Thank you, Nathan. I am Stephen Soltesz. I'm a software engineer at Google, and I work very closely with Measurement Lab. We call this model host managed deployments. You can think of this simply as a single server running software that is published by Measurement Lab, but installed and managed by the host organization. Could be 1, could be hundreds. Why would we consider this? All things considered, it makes it much easier to turn up. It invites deployment into new networks like access and edge networks. And it allows MLab to scale support for all kinds of hardware without needing to internalize all of the idiosyncrasies of every different version out there. How does this work? An organization would register with MLab by first completing the infrastructure contribution form, reviewing and accepting an MOU and data sharing agreement with MLab, and then MLab approving and finally registering the organization within MLab's platform. Practically, this is any physical or virtual server, a single IPv4 and IPv6 address, a minimum of 1 gigabit uplink, and again, a minimum of 4 gigs and 4 cores. Because populations and population capability and frequency varies, those minimums may not be appropriate at all locations. So where you would be contributing infrastructure would be part of what MLab is considering and approving. Right now, we are concluding a pilot with RNP, hopefully by the end of the year. And the goal is the general availability of this feature early next year. Next slide. Once an organization is registered with Measurement Lab, their servers can become part of the MLab infrastructure. The highlighted yellow blocks are components that are new to this host-managed deployment system. All of the others are identical components to the ones that are already running on MLab's platform. So a server would start and it would register with the AutoJoin API and get a dynamically allocated DNS name that represents only that server. It would also receive credentials and configuration metadata and distribute those to the other sidecar services. The heartbeat then registers with the locate API. At this point, this server is part of MLab's platform. Clients that are already running tests will eventually be given this server to target. They'll run their tests. The measurements are saved, archived to Google Cloud Storage, and then with the auto-loading system, published to BigQuery. Next slide. So MLab has been running a pilot with RNP. The collaboration began late 2023, so we've been working for about a year now, with the goal of deploying MLab servers throughout RNP's backbone network. Over the last year, this has given us time to develop the AutoJoin API, to make modifications to the data pipeline, and to curate a set of reference configurations for the measurement services that will run on host-managed servers. The target here is all of RNP of Brazil's federal districts. There are about 27. RNP has points of presence in all of them at about a gigabit each. Next slide. The current status since September of this year, these host managed servers managed by RNP have been collecting measurements. In the map in the lower left, you can see 2 red circles at Rio de Janeiro and Florianopolis. Those are both RNP contributed servers. Currently, those servers are seeing about 35,000 tests per day, or in total, that's about 20% of measurements conducted within Brazil. And in the lower right, you have number of hourly tests going to those 2 servers. Next slide. Because this is a new system and because MLab's mission is to measure the internet, we wanted to be sure that host managed servers would perform as well or better than our existing fully managed sites. Fortunately, MLab has a full site deployment in Florianopolis, FLN01, and RNP deployed, one of their first deployments was to Florianopolis 11242. That number is the ASN, one of RNP's ASNs. So the population of all MLab clients may be targeting one of these servers based on the selection mechanism in the locate API. And roughly it's random. So we looked at performance distributions of download tests, upload tests, the min RTT and loss rates, pictured are on the left is the download performance rate, on the right are the upload performance measurements. In these cases, we took the geometric mean of all of these measurements and found that in all cases they were within 5%. We ran other measurements, but in total, they've given us confidence that it's safe to continue this deployment. Next slide. I want to acknowledge the collaborators that have made this pilot possible. This is Marcos and Leandro at RNP, Daniel on the technical side, and Edmundo for putting RNP and MLab sort of in the same room. This would not be possible if it had not been for all of you, so thank you. What's next for host-managed deployments? MLab is going to continue the support with RNP to deploy to their remaining districts until that is complete. MLab is currently inviting new organizations to run host-managed deployments. And because measurement quality is so important to MLab, and because these systems are host-managed, they may change over time. We're looking at ways of continuously validating the measurements that come from them. And the data is not publicly available yet, but it will be soon. And it will be in a table that looks very similar to that name. Next slide. If you are interested in contributing some kind of infrastructure, any of the ones that Nathan described or host managed, please fill out the infrastructure contribution form. The deployment requirements are available on the website. If you know someone who might be interested, you can share a link to today's slides. And the recording of this presentation will be available on YouTube very soon. Are there any questions about host-managed deployments or any of the other topics we've discussed today?
There was some discussion in the chat about the TCP congestion control algorithm at Fastly. Roberto, do you just want to speak? So in case others didn't see, would you like to share what your response was?
Yes, basically we don't know yet, but we've asked, and it'll eventually be included in the result rows in BigQuery.
If there aren't any questions, we can give people back their time, but we do have all our engineers assembled, which is perhaps a rarity. So if there's anything you'd like to talk about with MLab, or if other people on the MLab team want to bring anything up for discussion, please.
I wanted to just briefly mention that I mentioned the minimal site deployment of just a single server, but I didn't mention if anybody was currently using it. And I wanted to acknowledge that there is one measurement site in the San Francisco area that is generously donated by the Internet Systems Consortium, the ISC.
Great, thank you, Nathan. Any last opportunity for questions, comments? It's a shy group today, I guess. Thank you all for coming. We hope this was helpful. I certainly learned a lot, even though I already work here. We appreciate you coming out. And if you do think of questions afterwards, we do have our email. You could reach out to hello@measurementlab.net. And yeah, we're always happy to answer questions. So with that, we can end the meeting.